All right, this is Geometry A, Unit 5, Lesson 7. We're talking about the hypotenuse leg theorem. As soon as we bring in the word hypotenuse, we know we're dealing with a special kind of triangle. We're dealing with a right triangle. And that's what I've got here. I've got two right triangles that share a side. And you may recall that when we share a side, any side is congruent to itself by the reflexive property. Reflexive property. Anything equals itself. You're just as tall as you are. Your hand is just as wide as your hand. The chair is just as tall as the chair. Anything is congruent to itself. It's a reflex. It's not reflective. It's reflexive. It's like when the doctor hits your knee with a rubber mallet. He's testing your reflexes. It's reflexive to say anything's congruent to itself. Right? Now that said, these triangles seem to follow a pattern of angle, side, side. Angle, side, side. And we've already stated that angle, side, side doesn't work because it is possible to generate two triangles that are not congruent but that share an angle and two non-included sides. Well, in this particular case, it does work because it is a right triangle and only one triangle is possible in this case. And so rather than angle, side, side, we call this hypotenuse leg. Note that one of the congruent sides needs to be the hypotenuse. The hypotenuse is the side opposite the right angle. Opposite the right angle. It's the long diagonal, the hypotenuse. And the leg is any one of the other two sides, right? And so these triangles share a congruent hypotenuse, and they share a leg, so the legs are congruent. So by hypotenuse leg, these triangles are congruent. Let me show you or demonstrate this in Desmos. I've constructed a right triangle. Let me go through the steps of constructing that again. I drew a line segment. I then used the perpendicular tool to pick point B and click on line AB to construct a perpendicular line. And then I'm going to put a point on that line, label it C, and draw the polygon here. Okay, polygon tool. Come on. Polygon. Oh, it's doing it again. Let me use the mouse. Okay, put a point on the perpendicular line. Use the polygon tool. A, B, C. Excuse me. All right. All right. Good. So we've got a right triangle that we've constructed, and we can move it around and change it. Right, by swinging this side around, moving point C to change it, moving point A. Okay. All right. I want to construct another triangle, another right triangle that has the same measurements, and so then we'll see the same hypotenuse and the same leg. Okay. So let's draw first of all a right angle here. So I'm going to draw a line. And a point not on the line, I'm going to draw a perpendicular to that line. Perpendicular. Perpendicular bisector. Perpendicular line, there we go. Point and line. So this line is perpendicular. Right angle. Okay. And I'm going to measure AB. AB. Yeah. Measure AB. So I'm going to use my compass tool to measure AB. And I'm going to go over to E, and I'm going to place that and place a point on the intersection of the circle and the perpendicular line. So EF is the same length as AB. And now I want to measure AC, the hypotenuse. Measure AC, the hypotenuse. So measure AC. Good. Copy that over to F, and put a point on where it crosses the perpendicular, and connect that with a segment. Okay, so I've measured AC to be the same as FG. I've measured BA to be the same as EF, and we started with angle E here and angle B being a right angle. So it satisfies the condition of hypotenuse leg, and let's draw our polygon. F, E, G, and back to F again. And let's measure it. Let's measure it. Measure what we know here. We know that angle B here is 90 degrees because we set it up to be perpendicular, and so is angle E, 90 degrees. We know that, measure length here, we know that side AB is the same length as side FE because we measured with our compass. We know that side AC is the same length as side FG because we measured with our compass. What I don't know is the remaining fact. So let's test and see. Is BC the same length as EG? Yes, it is, 2.8. Are the other angles all the same? Let's measure some angles. Angle A, 37.3. Angle F, 37.3. Angle B we already measured. Angle C, 52.7 degrees. Angle G, 52.7 degrees. So the other facts do agree, and it doesn't matter if I move things around. As I change point C, it changes, and so does the other one. Now, as I rotate angle A, the other one doesn't rotate, but check the measurements. 3.5, 3, 4.6, everything stays the same. So as I change, all the measurements stay the same. As I change B on the original, all the measurements still match. And so it is confirmed. Hypotenuse leg does prove triangles congruent.